When we are given the equation or function rule of a quadratic function in either standard form or vertex form, we can graph that function. In standard form as well as vertex form, we're first going to graph the vertex and the line of symmetry. In standard form, we're also able to immediately graph the y-intercept, so we have an additional point given to us. And then with standard form, we have to graph one additional point. Vertex form, the only easy point that we have access to is the vertex, and then we have to find two additional points and reflect them. Let's start with standard form as our example. So finding the line of symmetry is a little bit of work with standard form, but we know how to do that. We use our opposite of b over 2a formula. So -4 over 2 times -1. -4 over -2 is 2. So my line of symmetry is x equals 2. So opposite of 4 over 2 times -1, -4 over -2. Line of symmetry on the line x equals 2. Then we plug in 2 into our function rule, find f of 2 to find the y value of the vertex. So -2 squared plus 4 times 2 plus 5 is -4 plus 8 plus 5. -4 plus 8 is 4. So my vertex is x equals 2, y equals 9, and I can plot that point. There's my vertex. The y-intercept is very readily accessible to us just from the standard form function rule. It is 0, 5. Up to here, none of this is new information. So opposite of b over 2a to find the line of symmetry and the x-coordinate of the vertex, plugging in that x-coordinate to find the entire ordered pair or the y value of the vertex, and then the y-intercept just from the function rule. The new information that we need to know or use for graphing the function is first we need to reflect the y-intercept. So we did this with absolute value functions. This point, this y-intercept, is 2 to the left of the line of symmetry. So recognizing that symmetry, we find this additional point. So now we have 3 points on our graph, 2 to the right of the line of symmetry. So we did that. The last step for graphing from standard form is to pick an x value to the right or the left of the vertex and plug it in. So we could plug in x equals 1 or x equals 3. I'm going to plug in x equals 1 since it's a smaller number. Just picking an x value close to the vertex ensures that the point will actually be on the graph. If I were to find like f of -7, it would not be on this grid. So I'm going to find f of 1. That's going to be -1 squared plus 4 times 1 plus 5. -1 plus 4 plus 5. And it is 8. So now I have an additional point, x equals 1, y equals 8, x equals 1, y equals 8, that's right here. And then I will reflect that point over the line of symmetry. This is what we consider our graph of our quadratic function. We require 5 points. For standard form, that's the vertex, the y-intercept, the reflection of the y-intercept, and then one additional point, where that additional point is chosen because it is close to the vertex, and therefore we know that it is on the grid. So I reflected that point, sketch the graph, remember to include arrows. Yep, so we're always looking for 5 points. Vertex, y-intercept, reflected, additional point, reflected. That's standard form. Vertex form initially just seems much nicer. We can identify the vertex, -1, -3. We can identify the line of symmetry with no work at all. However, that is where the easy parts stop. Now we have to just plug in 2 x values to find additional ordered pairs because there's nothing else that we can just identify from the function rule. I could transform this into standard form to find the y-intercept. I'm going to instead see that I can just find my y value when x is 0. That's another way to find the y-intercept. And really, I'm not required to find the y-intercept for vertex form. I just need to find 2 additional points where the x value is close to the vertex. So I'm going to plug in x equals 0 and x equals 1. F of 0 is, like I said, another way to find the y-intercept. What is the y value when x is 0? Let's find f of 0. 2 times 0 plus 1 squared minus 3. 2 times 1 squared minus 3. Negative 1. So if I I'm allowed to, I could have transformed this into standard form and then found the y-intercept to be negative 1. This is a faster process, though, plugging in 0 for x rather than transforming into standard form. Just need to reflect that point. 1 to the right, now I go 1 to the left. I have 3 points on my graph, which, by the way, I can see this is steeper from that 2. I went up 2 over 1 for my first point. And I could see this is a correct a value, down 1 over 1 for my first point. So my next x value I'm going to plug in is x equals 1. Again, I have the vertex, and then I'm just choosing x values to evaluate for that are close to the vertex, because if I found f of 7, that would not help me because it would not be on the grid. F of 10 would not help me, it would not be on the grid. So I need something close to the vertex so that it's actually there to help me graph. F of 1 is 2 times 1 plus 1 squared minus 3. Correct order of operations, inside the parentheses first. Then the exponent. Then we multiply, and then we subtract. That gives me my next point, 1, x equals 1, y equals 5. 1, 2, 3, 4, 5. And I'm just going to reflect that point, 2 to the right, 2 to the left. And that gives me my 5 required points for graphing a quadratic function. Again, for vertex form, I have the vertex and the line of symmetry just from the function rule, and then I have to find 2 additional points and reflect them. Standard form, it was just 1 additional point because the function rule gave me the y-intercept.